So hey guys, welcome back to the channel. This is Yagesh Bobre, and again we are back here with another fundamental video about programming. So we'll cover basic topics in this video. Actually, let's directly look at the overview. And before we begin, I'd like to introduce myself. I'm Yagesh Bobre. I'm a first year BTech student at Ramdev College of Engineering and Management. I have experience in web development and programming. I've been doing this for more than a year and a half, and if you want to look at my experiences, you can find them on LinkedIn. I've linked that in the description below, and check whether I am capable of teaching this stuff or not. But I'm going to be very frank with you. I don't feel like I'm the expert in these fields that I teach, and I'm nowhere near an expert level. But I do believe that the concepts that I teach are at a level, and I've experienced working with them. I do understand them to a very good level, and I'm able to explain them well. So that's the only reason I'm creating this video, for the learning purposes, for my sake as well as your sake as well. So if you feel like these videos are helpful, then please just continue to watch them, right? Nothing else. I don't need anything else, because I'm not doing for any monetary gains or anything. I just do it because I like it, right? So yeah, so I think that's enough, and let's get started. So first we'll look at the overview, what we'll cover, the topics we'll cover today. Okay, so what is computer programming? Why is it required? The different programming languages. We'll look at each one of them, right? Then the compilation step. This is very important. The mechanics that goes in the backstage, right? That is the compilation process, right? Some system software. So during the compilation process, some softwares are required, some programs are run. Those are basically translators, linkers, and loaders. We'll look at them one by one as well. Then basically computer programming is problem solving, right? So we'll look at how problem solving works. This is a four-step problem solving cycle. And then we'll take two examples and try to understand the pseudocode, algorithm, and flowchart. Okay, so that's the overview of what we are going to be learning today. I think we'll just get started, right? So what is computer programming? See, we have all this hardware, we have the computation power, right? We have all these high-tech computer stuff, we have these high-powered RAMs, GPUs, right? But without giving them instructions to do something, they are just useless piece of metal, right? So what a computer program does is it gives them that instruction to perform a certain task. Maybe we need to solve a particular problem. Maybe we just need to add two very large numbers, and we need computation power for that. We need some space on that RAM. We need that to get working, right? So we'll construct a program, we'll write a program, we'll instruct that we need to add these two numbers, and then we'll use the hardware to perform that task. So that is what programming is used for, to give instructions to these hardwares to perform our operations, to perform our tasks, right? So that is the process of writing that program is called programming, right? And the instructions that are written, that is basically our source code. Okay, so you can just look, each of these slide has more information than what I'm telling in a proper structured manner, so you can just go through them one by one, right? What is a computer language? See, our computer is a very dumb machine in a way. Okay, so the only language it speaks is zeros and ones, the binary language. So any data we have, any information we give it, it only reads it, it encodes it in the form of binary, zeros and ones. Okay, so it's hard for us to communicate with the computer directly. Okay, and since this language barrier is a problem that we face, what we do is we write our code in high level languages. Basically, we use programming languages to write our programs. Okay, so let's look at them. A programming language, basically a language which is used to write the programs, write the instructions that we want the computer to perform. Okay, then we'll look at three different categories of programming languages. Okay, machine language, assembly language, and high level language. Let's look at them one by one. So we have machine language, basically the language that computer speaks, the machine speaks, right? The binary language, the zeros and ones, right? That's what machine language is. It's a natural language for a computer. Okay, it's the binary code, and any other language that you're going to use, any other programming language that you are going to use. You might have heard C, C++, Python, and all different kinds of languages, right? And any of them, you can't expect the computer to understand them. So first, that language is to be converted into down to this level, to machine language, and then so that the computer can understand it, right? So that's what happens. The second is the assembly language, and it's a little bit easier than the machine language. So it has English like abbreviations. For example, I've given an instruction here, so like move ax comma 4, that basically stores the 4 value in the ax register, right? So that is what mov represents. Then we have the add operation. So we'll add whatever is in the ax register, that is 4, and in the bx register, that is 6, that the result is 10. That will be stored in the ax register. So in ax now 10 will be stored. So this is assembly language. It's a little bit easier to understand than just a bunch of zeros and ones, but still it's still a bit complicated. So here we still had a need to improve programming languages. We needed a better system of communication. Then we have our high level languages, the solution to our problems. So these are very similar to our English like syntax, and they're easy to learn because of the very same reason. For example, here we have an example, like we have a price variable, or you can just assume that these price and tax, each of these name contain a value within them, right? So let's say if this was 5, if this was 3, and we can directly give the plus operator in between, and you'll get the operation, the answer as 8, and it will be stored in this total cost variable, right? And similarly in area, we have the multiplication operator as well. So it's that simple. You don't need any complicated system, right? You don't need any complicated grammar for this language. You can directly write the operators as is. Okay, these are the examples of some of the high level languages, right? Now that we know what programming language is, we need to understand how these high level languages that we use are converted into machine language, right? We need to understand how the computer understands them, because we already know computer can't speak that language. So what happens is there is a back process going on, which is called compiling, right? So the compilation process is basically converting a source code to a machine code so that the computer can understand it and execute the program, right? So what happens is we have a source file, the source code, right? The source code, and we have a software, right? A compiler. Compiler is basically a software which converts one language to another, right? So a compiler, what it does, it gives out an object file or an executable file, okay? And you can read about it here. Program called a compiler is used to translate the source program into a machine language program called an object program. Okay, so compiler basically converts into a machine language program that is an object file, right? Now we have what a software called linker. What it does is, if you have any other object files needed for this particular source code, right? You remember in C programming we have a statement at the top, hash include iostream, or hash include standard io.h. So what linker does, it links that standard io.h module with the current source code, right? So linker basically links two or more object files together as and when needed, and it generates a final executable file, or it might just be an object file, another object file as well. And if you want to run this executable file, you'll have a program called loader. So what loader does is, it loads this executable file from the secondary memory to the main memory for execution. If you don't know what secondary and main memory is, I have created the video. I'll link that in the video as well. So that is loader. We'll look at loader, linker, and translator, or like compiler, in the upcoming slides as well. But that is the basic workflow, from source code to compiling to object file to linking, and then finally the executable file. You can directly run this executable file uh, to to do the task, right? Now, so basically I have given the definition of a compiler. Basically a compiler completely transform that source code to a machine code, right? Source code to machine code, right? And this machine code is basically the file generated is basically called object file, or the code is called an object code. Okay, it doesn't really, it's just a terminology. Okay, and if the source code contains some errors, this object file will not be generated. Okay, this is what is written here. Now, interpreter. Okay, interpreter is a bit different than compiler because it doesn't require the compilation step. The language like Python is an interpreted language, so it doesn't need that compilation step. Okay, it directly runs any high level program to execute directly. This does mean that it takes a longer time, but overall the advantage is that it can immediately execute. Okay, in compilation what we happen is we first need to convert that program, and then that executable file that is generated, that can be run. But in interpreter you can directly run the program, and it will, this interpreter, what happens is this interpreter converts the instruction, the program, into an intermediate form that can be run directly, right? So the problem is in like interpreter versus compiler, although the compiler has more steps, the executable file that it generates, exe file that it generates, is much faster than the interpreter language, right? Because it directly runs the program, right? So the running time of compiled language is much more than the interpreted time. This is a kind of an advanced concept, so we'll look at that later as well, but this is the basic idea. Okay, now some system software that basically help in this compilation process are translators, linkers, and loaders. Okay, now translators are basically system software that convert the source code into any language that you, in some particular language that you want. Okay, the target code. So we'll look at compilers and assemblers for now. We already talked about compilers, right? It converts high level language to machine code, or basically it gives us an object file, the object code for a particular source code, right? So some high level languages include C++, Java. The machine code generated by compiler is called object code, right? You already looked at this, so it's just a brief overview. Assemblers are basically software that convert the assembly language into machine level language. Okay, so it's that simple. Machine level language uses corresponding binary operation code for each of the mnemonics. See, this assembly language uses mnemonics like add, subtract. We saw that in that example, right? So machine level language already had a binary operation code. Like this add can be represented as 0, 0, 1, 1, 0, 0, or something like this in zeros and ones. It already has that particular code set for it. Okay. Now, linkers, as I told you, they link two or more object files, right? We have this one object file, this another object file. They will link the two as and when needed. So let's say this is our source code. This is our source code, and we need this standard.h file, right? And we also need this math.h module, right? We already have this in our computer, but we need them in this our main source code that we are running right now. So linker will link both of these files with this main source code file, right? And now we can, in our source code, we already have these two files linked, so we can use the functions from these two files as well. So that is what a linker does, combines two or more object files into a single object file or an executable file. Okay. Now we have loader. As I told you earlier, loader basically loads in the memory, in the secondary memory, we have program stored, right? Or we have the executable file, right? The loader takes it and basically brings them to the main memory. That is the RAM basically, right? In this case, it's the RAM. Why RAM? Because RAM is where all the execution happens. Okay, it's the fast memory. It's volatile. So any execution that happens, it happens here, and then the data is finally stored in the secondary memory. The secondary memory is long-term storage, and RAM is the execution storage basically. Now that we know how the program is actually compiled, the back process, now let's actually get down to understanding programming, right? How we write it. and basic programming fundamentals. We won't go into the coding part in this video, but we'll understand some basic uh, ideas behind it. So, and these are common to all programming languages, okay? So sequential processing, basically a list of instructions, very clear to understand. Now conditional execution. This is important. Like, let's say if uh, I get an A grade, if I get an A grade, what I want to do is I want to give a party, right? Right? If else, like else, let's say if I get a B grade, I just want to sit at home, right? And let's say else in any like in any third case, like for example, if I get C, D, or E, or anything below that as well, in that case I want to go to my friend's house to sulk, maybe, I don't know, go to my friend's house. So what is happening here is we are giving it a certain condition, and anything inside these brackets will only be run if this certain condition is met. I hope you're able to understand this. That is what conditional execution means, okay? So running a block of code, running some statements only when the certain condition is true is basically conditional execution, okay? Now we have repetition. So first let's erase this. Now let's look at repetition. So let's say I want to print my name 100 times. So see, if you're using C language, we have a printf function, okay? So anything in printf, like in double quotes, will be printed. So I'll write Yagesh. And this Yagesh will be printed out on the screen directly once, because I have written the printf statement once, right? And if I write it again, like if I write again printf, so when I compile this program, execute the file, then I'll get 2 times Yagesh, right? Written Yagesh and then Yagesh. But to write it 100 times, I would have to write the same thing 100 times, right? That would be too much work and too much repetition. We are coders, we don't do that. We try to eliminate any repetition of code, right? So in this case, what we'll do is, since we only need to run this one line again and again, what we'll do is we'll use what are called loops, okay? So what we'll do is we'll create a loop and we'll run this 100 times, right? Up for now our requirement is 100 times, and in the loop what we want to do, we'll put this in this brackets, right? So anything inside this bracket should be run 100 times. So that is the concept of looping, repeating something again and again. So what we want to do is we want to just print. I'm not using the proper syntax right now. I'll just write Yagesh. So I needed to print my name 100 times, and this is what that code will do. It will run this line 100 times. So that is the concept of looping and repeating, okay? So now instead of 100 lines repeating again and again, now I only have this 2 or 3 lines giving us the same output, okay? So you can see how the code got much simpler, right? And much shorter. So that is why we use loops, right? Then we have methods, functions, and procedures. So for example, let's say it will be hard for me to explain functions in depth in this slide, but I'll try to do it anyways. Let's say there is a bunch of code that I've written. Like for example, I say that I'll take a number A, I'll take B. Each of these numbers will store a value, and I'll return A plus B directly. Right? First, let's say I took A is equal to 10, B is equal to 5, and then I'll return this, or I'll print the output on the screen, A plus B. So that will give out 15 as an output, right? In the next case, let's say I wanted 2 other numbers. So I took C equals to, let's say I took 6 and D equals to, I took, let's say, 7. Then again I did C plus D, I printed the output, I got 13 as a result, right? But I'm doing the same thing again and again, but I'm writing the same 2 and 3 lines. Let's suppose I also wanted to print the multiplication and division, etc. A into B. So this will give out 50, right? So this will give out 50. So I'm repeating these 3 lines of code. As you can see, I'm having two numbers again. I'm giving C plus D. I'll also give C into D. Maybe also have C by D, right? So I'm only repeating these 3 functions again and again. So what I could do is, I'll create what are called a function. Function is a block of code that you can group together and you can call them anytime again in the program. So let's say I name it add numbers. I created this function. I gave it a name. Okay. And I'll take in 2 arguments. Let's say A and B. These 2 could be any values. Okay. And now I'll run something in this. So we want to print A plus B. So we'll print it out. And we want to print A into B, we'll print it out again. We want to print A divided by B, we'll print it out that as well. Now in the upcoming code, right now we haven't given A any value, B any value. Okay, these are just variables that we have assigned. Okay, now in our main code, when we actually want this output for 3 different numbers, what we'll do is we'll just call add number. Since we have created this function, we can directly call add number function. We can provide the values 5 and 3 like this, and this 5 will then be stored to A, this 3 will be stored to B, right, correspondingly. And since we called this in this function, what happens is these 3 lines are run. So we'll get the 5 plus 3 value, that is 8, the 5 into 3 value, which is 15, and 5 divided by 3, which is basically 1 point something, so 1 will be printed out. And again I can run the same line again, add number. Now this time I'll give different values, for example 10 and 2. So now 10 will be assigned to A and 2 will be assigned to B. Similarly, these 3 lines will be run again for these 2 values. And as you can see, we have reduced the number of lines so much, right? Instead of running these 3 lines again and again for this, right, now I only need to run this 1 line and our values are changed, right? So that is why functions are used, to reuse a written code again and again in our program or in another program as well, and calling a segment of code somewhere else. So that is the uses of functions. If you don't understand it entire, I mean, that's okay. It's okay to understand a bit of it right now. We'll also cover this in later parts of a series. Okay. Now, methods of programming. Again, this is, if you understand it fully, great. If you don't, it's fine. Okay, I'll just try to give a basic idea about this. See, procedural programming is basically just giving a set of instructions stepwise, right? Do this, do this, do this, do this. That's all procedural programming is. Okay, then object-oriented programming is different, because let's say you have a problem and let's say you want to get an average of all the students' marks in a class, right? So in procedural programming, what you will do is you will get a student's marks. So let's say student 1, you'll get all his marks. So you'll run 3 lines of code, marks 1, marks 2, marks 3, right? M1, M2, M3. Let's say there are only 3 subjects, and then you'll sum it up. Okay, you'll sum it up, you'll divide by 3, and then you'll print the average, right? That is basically the average. The sum divided by 3, that is average, right? So that's the procedural step. And then you will do this again and again. Basically you loop it for all the students, right? But a better, if you have more data, right, not just marks and not just 3 subjects, you have more things like roll number, and you have to perform more operations as well. Roll number, marks, section, the phone number, etc. You have all these details. So what you could do is you can have another approach. You can define an object. Okay, so you'll have something called a student object, and that student will contain all these details: roll number, marks, and section, and phone number. So I can create a stu student1 variable name, like you have variables in like x and y in maths, right? Similarly, stu1 student1 is just a variable name, and what the value will give it is a student. Okay, so here we created a student object. Now we'll create a variable name student, and we can pass in like information like roll number 1, the marks he got was like 32, 33, 34, etc. And the section, its section is A, then the phone number is 8639, etc. So now all the student information is now stored in the student variable. You can create all the students like this, and for all of them you can create, for the student object you can create a separate function like an average function. Actually, I'll erase this. So see, you have this student object, right? You created this yourself. These are called user-defined objects, right? This is a part of object-oriented programming. So and you defined some of its values like roll number, marks, section, phone number, etc. Now you can also define methods for this student, right? You can define a function, you can create a function which basically calculates the average, right, by using the marks. Okay, so whenever you want to get the average, all you have to do is you will write in the last slide, we actually defined student1 variable, right? Now we can just write dot average like this. So we'll call that method that we have defined in this for the student object directly, and we'll get the average. Similarly, if we had a student2, we'll just have to write student.average. And we can also create other functions in this object, functions like maybe get phone number, right? So in this, we'll just, the code inside this function will write just print phone number, right? Print the student phone number, right? And we haven't explicitly stated what phone number it is. It's using anything stored inside the student. So for stu1 we gave something like 8 something something phone number. That phone number will be printed out. So if I call stu1 dot phone number, get phone number method, now the phone number for stu1 will be printed out. So you see how much lines I'm saving with this, and it's much easier to store all this information in just a single variable. And if you are confused, that's totally okay. This is an advanced concept, and it's okay to take only a little out of this. Okay, let's move on to 4 steps of problem solving. So see, computer programming is basically problem solving, right? You need to solve a task, you use computers for that, you program something to solve your task, and that is what computer programming is, and that in essence is basically problem solving. So there's a 4-step cycle, UDIE. The first step is understand the problem, right? This is very important. And second is devise a good plan to solve. And in these 2 steps, you will be spending most of your time. Okay, like 70 to 80% of the time will be spent. It's okay to spend like 60 to 70% or 70 to 80% of your time on these 2 steps. Why? It's very simple. Understanding the problem, ask question about the problem and try to understand what we have to do. Okay, like what we have to do. Okay, and like try to understand each edge case. Okay, the exceptions, like what happens if I put 0 in it, is will there be an error? Like if you have to perform division, 0 might be an exception case that you need to consider. So consider all the edge cases that you can. If you have a question, ask the question. If someone is asking you a question, you can ask them questions about the problem as well. Or if it's a platform, or if it's an online problem, then okay, fine. You can just create as many questions as you can, try to answer them if possible with the given information, and try to better understand the problem. That's the first step. The second step is devise a good plan. So this is basically kind of an ideation phase. You try to find an approach to solve the problem. It doesn't have to be a definite approach. You'll just create like steps, like I can do this, then this, and then this. So now, yeah, that will solve the problem. So you have to devise a good plan, okay? And it's okay to take your time doing this, okay? And if you feel like you're better at writing stepwise, you do that. That's called an algorithm. Second, if you find it better to draw diagrams, a mind map, a flowchart, whatever you feel good, you can do that. Ultimately, our goal is to solve the problem, not on how you approach it. Okay. So take your time, devise a good plan, and don't jump. Whenever you see a problem, don't jump to coding. Okay, coding is the easy part. I'm repeating this. Coding is the easy part. These are the two important steps. If you already know, like if you have a good plan, it won't take you long time to solve that problem, to code that problem. Okay, so it won't take much time for you to code the solution. You will get errors, and those errors can be solved uh, stepwise, right? You'll just focus on one error at a time and you can solve it. So my suggestion is take your time in these first two steps and then go for the coding part instead of directly jumping to it. So I've given some points here, you can read them, right? Now in the second step, we have three important things: algorithm, pseudocode, and flowchart. We'll try to understand these with two examples. So algorithm is basically that I told you, right? The step one, you have to do this. Step one, you have to do this. Step two, you have to do this. This is basically an algorithm. Okay, the stepwise procedure that you have to follow, that is algorithm. The pseudo code, basically you don't write the exact code. Pseudo is like false code, right? Pseudo means false. So you don't worry about things like syntax and stuff. You just continue to write, like if something happens, I want to do this, and maybe I'll have a loop here, maybe I'll have a for loop here, I'll do this. So you see, I'm not following a proper syntax. I'm just writing that I'll use for loop. Maybe that's a for loop is just a kind of loop, right? We studied loops, right? So I'm not worrying about the syntax. I just want to give a basic idea of how the program will work, and I'm just writing a basic code for that. Flow. Now, flowcharts are basically the visual representation, and there are some standard images, standard shapes that you use for flowcharts. You can see them here. You can represent the start and end of the program by this, right? You can like something like start here, and arrows are basically give the direction in which the program is working. These are basically the IO and the input from the user on the output on the screen, the processes and the decision. This is basically the condition, right? Okay. Now let's actually see the two examples. So here we have a question whether a number is even or odd. Okay. Draw a flowchart for the program. So I think the question is very clear. We will be given a number and we have to tell whether the number is even or odd. It's that simple. So first let's ask ourselves a question like, how do we tell? See, we understood the problem. Now the second step is, how do we tell whether a number is even or odd? We have to devise a plan, right? So we know that any even number is divisible by 2, right? So that's our plan. If we get a number, let's say 3, we divide it by 2 and we get the remainder 1. That means it's not divisible by 2 and it's an odd number, right? So we can check the remainder for every number divisible by 2. Okay, if the remainder is 0, then that number is even. If not, then that number is odd. It's that simple. That's the logic behind it. Now let's try to draw the flow chart, right? I have a terrible drawing, but let's start anyways. So first we'll give the start. Here the program is started. Then the next step is enter the number, right? The user will be asked to input a number n. So input n. Next we have to check the condition if that n is divisible by 2 or not. So for that we'll write a condition, right? So n, And for the remainder, we have this percentage. The modulus operator is basically says the remainder when n is divided by 2. And if that remainder is equal to 0, that is what this condition says. So if the number is divisible by 2, that can be written, that is written here. If yes, let's say, yeah, the number is divisible, I mean the remainder is 0, then we can display the output as even, like we can print even, right? And if no, if the remainder is not 0, that means the number is odd. So we can show the output here as odd, right? And that was the goal of a program, wasn't it? So here we can stop our program. So I think that's a basic flowchart. That's the basic thinking process that goes behind a problem solving. Right now you can implement the solution. You have the basic idea of how to solve this problem. You have the steps all in mind. Now you can directly code it. You won't Now your coding process will be much faster because you won't stop or you won't be confused on what to do. You already have that planned out. That is why that is why I feel like you should give more time to the second step. Okay. And I know this flowchart is terrible, so I'm going to show you the proper flowchart. So here you can see I have, for the same question, I have the flowchart here. We'll enter a number, and if that number is divisible by 2, if yes, we'll print even, if no, we'll print odd. Now, I've also given the algorithm and the pseudocode for this very problem. The algorithm is written in steps like this: start the program, read the input. If n is divisible by 2, then the number is even. If not, then it is odd. Display the output and stop the program. So that is how an algorithm is written. And in pseudocode, we have the if statement written. If you don't understand the pseudocode, that's totally fine. But basically, if condition is written, integer modulo 2. Modulo is this percentage operator, this percentage symbol, right? So if that is equals to 0, that means the remainder is equals to the 0, then print number is even, else print number is odd, right? And then end if. That is the pseudocode. Now let's see a little bit more of a complicated problem is flowchart for a prime number. Now the question is, we have to determine whether a number is prime or not. So we understand the question, we have to find whether a number is prime or not. Second step, decide a good plan, right? So we need to first understand the logic. So how do you know whether a number is prime or not? So the definition of prime is the number should be divisible by 1 and itself, right? So 1 and n, right? And let's say if I have a number 10, I know that I have a number 10. I know that it's not a prime number, but for a computer, how can we tell, right? So what we can do is we can divide it by every single number behind it to find the factor, right? So we can start dividing it by 2, right? So when we start dividing by 2, we see that it's divisible by 2. That means 2 is a factor and 10 is not a prime number. So let's take another example. Let's say I have 37. Okay. Now I'll start dividing it by 2. We see that it's not divisible. Then I'll go to the next number, 3, right? Is it divisible by 3? I would say no, it's not. Then I'll go with 4, and again, not divisible, 5, and so on, right? It's not divisible. I'll go all the way till 36 and 37. All the way till 36, right? And we'll see that it's not divisible. And after this, after we have checked all numbers till 37, from 2 to 37, we'll say that yes, this is a prime number, right? So we'll have to check a number each and every time, right? So that is the logic behind finding a prime number or not, right? So now let's try to understand the flowchart. We start the program, then we have we have created two variables, the flag and I equals to 2. See, this I equals to 2 is the number that we started from, right? We started from 2 because we already know 1 divides every number, right? So we started from 2, okay? So that is what I is. And we know that we have to change I, like we started from 2, but we have to increase from 3, 4, 5 all the way till 37, right? Or the number that we have. So read n from the user, that this is the number. Now we also, in the first question I told you, right, we have to consider the edge cases. So if the number is 1, that's an edge case, right? Because 1 is neither prime nor composite. So if the n is 1, we can directly say, as you can see here, if the number is less than equal to n, if this is true, then we'll say that n is not prime, and we'll directly come to the stop, right? So yeah, that is an edge case that we have to consider. So we said that, and if no, now we have to implement the main logic of the prime number. We'll say that I is less than equal to 2, less than n divided by 2. We'll cancel this. This is more of an optimizing part. So we'll go from 2, from I is equal to 2, we'll go all the way up till I is less than n. That means if the number is 37, we'll start from 2 and then we'll go till less than 37, that is 36. We'll go all the way till 36, right? So here, if this is true, if the number is less than 37, that is, if the number is between 2 to 36, we'll move on to the next step. We'll try to divide the number, right? We'll try to divide 37. First, we'll try to divide it by I. I is basically in first iteration, it's 2, right? So we'll check if that's divisible by 0. If the remainder is 0, that means is 37 divisible? If yes, then flag is set to 0. See, we have to set a variable, right? We have to set whether we found a factor or not. So in this flag, we have written 1. Basically, this flag is used to determine whether the number is prime or not. In the end, as you can see here, we are checking if the flag is 0. That means the number is prime. Okay. And if not, then n is not prime. Actually, there is a mistake in this code. This has to be no, and this has to be yes. Let's see, like if a number divides it, then we'll say that the flag is 0. Okay, and then if we check it here, we found a factor, right? That means the number is not prime. So if the flag is set to 0, then the number is not prime. So we are using flag for that purpose. And if after running all this code, if the flag remains 1, then it will go into this side of the condition and it will print n is prime. So if flag is equal to 1, that means print n is prime, and if flag equals to 0, that means n is not prime. Okay, so here what we are doing is, we'll check. Here we are checking whether the number is divisible by I. If not, if it's yes, then we are changing the flag and then we are moving out of the loop. See, if like in between 2 to 37, if we find out that 37, let's say 35 actually, let's say we know 5 is a factor, right? So from 2 we'll start, then we'll check with 3, then we'll check with 4, and then check with 5, right? And when we check with 5, we'll find that it's divisible. So we don't need to check with the rest of the numbers. We don't need to check with 6, 7, 8 or 9. We already know that since 5 is a factor, this is not a prime number. So we can stop checking right here. So when flag was set to 0 after this division, we directly came here and exited from this loop that is going. So you see this arrow right here? It's going back, right? So that means this is a loop. And that loop is being run until this condition is satisfied. That means as soon as the number, the I reaches 37, see the condition is I less than n. That means until it's 36, this loop will run. But as soon as it turns 37, the condition will be no and will directly exit from the loop. Okay, so that is the how a loop is represented in a flowchart. That is how condition is set for the loop. Okay. So if the number is not divisible, if the number is not a factor, what we'll do is will go and will increment I by 1. That means first we our number I was 2. Now we also need to change that, right? We need to increase I by 1 every time, right? So we'll increase I by 1. That means it will go 3 right here, and then after it's 3 it will check here, it will go here, and now the next step is the condition. It will check if 3 is less than 36, is less than 37, and yes it is, so it will continue with the loop. Now it will check if 3 divides n. If it does, which it does not, so it will again increment. So now the I will be 4. Again it will check condition, it will go back, check condition, and that condition is true, so it again goes inside the loop. Okay, now let's say if the number was 16, in the case of 4 this number would divide, it was divisible by 4, then it would have gone here and the flag would have been set to 0, will go out of the loop, and then this flag condition will be checked, and since it's 0 it would have print n is not prime, and then the program would have been stopped. So I know this might have been a bit confusing for most of you guys, but if you understood this, that would have been a great leap forward to your programming journey. Okay, and I'll create more examples like this. I'll create separate videos on problems like these, okay, so that you better understand flowcharts and algorithms as well. But for now, if you don't understand this, try to rewatch the video and try to watch it 2 or 3 times more, okay? Now I also have given algorithm and pseudocode for this, okay? You can take a screenshot like here and try to read it and understand it. I don't think you'll have a problem understanding the algorithm if you understood the flowchart. You might have some problems in the pseudocode because it's using for loop, if condition, end if, end for, but it's fine. Since we haven't started coding yet, I haven't introduced you to the syntax, so that's fine if you don't understand the pseudocode, but try to read the algorithm, okay? Now let's come back on track and jump to the third step. Now that we have a proper plan, it's time to code the solution, okay? Step 4 is checking each test case, running the code. I mean, compiling the code, running the code, checking each test case. How is the output compared to what we want? Okay. If the output is wrong, then we go back, we tweak the code again, come back to the step 4. So now it's a non-linear process, right? We go back to the step 3, then test again with the step 4, go back to test 3 and do again with the step 4. Now the final step would be looking for new solutions. Okay. Now let's say our solution is completely working fine, okay, we have written all the solution, but the thing is, in problem solving there can be more than one solution to a problem, okay? So now your next goal is to find a better, more efficient solution. So you'll try to optimize the code, go back to third step again, optimize the code, maybe remove some variables so that the program takes up less space, try to reduce the code to a shorter size so that it takes less space, try to try to not include too many for loops that will take more time to run the code. So try to remove for loops if possible. These are just some of the ways that you can optimize your code, okay? So yeah, that's the step 4. So that's it for this video. I'll be bringing more content. I'll be having videos on JavaScript, CSS, HTML, as well as Python and C. So you have a lot to look forward to. So to stay up to date, just subscribe the channel, hit the notification icon, and if you like the video, hit the like button as well. And if you have any thoughts or comments related to the video or doubts, you can send a DM or you can write it in the comments below. I'll try to reply to them as fast as I can. Okay, thank you guys for watching and see you guys. Bye.